This example 2 is similar. It says use the function y equals x minus 2 divided by x squared minus 2x to answer the following questions. So it says what's the restriction for x, right? So to take the restriction, we take the denominator, we set it equal to 0, factor it out, take each factor equal to 0. So clearly the first one, x can't be 0, and the second one, x can't be 2. So we have two restrictions that x could never be. Then it says fill the table out, which we will. When x is -5, we will plug it in. -5 minus 2, that's what's on the top. The -5 quantity square, students, that would be 25 minus 2 times -5. So on the numerator, you can see this -7. On the bottom, that's 25 plus 10. So that's going to be -7 over 35. And yes, you have to reduce that down to -1 over 5, okay? Then we're going to do the same thing with -1 when x equals -1, plug it in. Let me pinch it in so I can see the equation again. Or maybe I'll just write it here. Y equals x minus 2 over x squared minus 2x. Okay. So when we are working with -1, similar process. -1 minus 2 over -1 squared. Actually, you should know that that's just going to be 1. Minus 2 times -1, that would be a positive 2. So that's going to be a -3 in the top and a 3 in the bottom. So that's -1. Now this -1/5 is what's going to trip out a lot of you guys, okay? So -1/5, y equals -1/5 minus 2 over -1/5 squared, students, that should be known as a positive 1 over 25. Minus 2 times 1 over -1 over 5. Whenever you have a negative and you square, it's always going to be positive. Now what's going to trip you guys out is this. The -1/5 take away 2. That's a larger negative. So that's -2 and 1/5. Just like that, okay? Then we have been multiplying fractions this entire unit. So when you multiply this, you just multiply the numerator with the numerator. So -2 times -1 is now positive 2 over 25. Now we have to add the bottom. So that means we have to multiply by the LCD, which is another 5 to make the LCD of 25. So I'm going to rewrite the numerator, -2 and 1/5, to become an improper fraction, which is -11 over 5. Then divided by, I'm just going to add the bottom. The denominator is going to be 25. On the top, this is 1 plus 10, so that's 11. Then we're just going to flip. So -11 over 5 times 25 over 11. Some of this is going to reduce. Can you see that? This is what we've been working along all this unit. So your final answer, student, is going to be -1 times 5 is now going to be a -5 for the -1/5. So I would like for you to take a couple minutes to work out the remaining y values for those. Once you're done, hopefully you got 5 here, 1 here, and 1/5 here. So let's compare really quickly. Students, look at those outputs, okay? Aren't those outputs the same as what we have above? Exactly the same. No difference at all. So isn't that weird that our equation, they look super different from the above, but our outputs are the same. So what that means is our graphs is going to be the same. So -1, 2, 3, 4, 5. -5, go down -1/5. -1's -1. -1/5, it's going to be 2, 4, 5. It's right here. So make that left curve. Okay. And then do the right curve. 1/5, 2, 4, 5. 1 is 1, 2, 4, 5. Go up 1/5. Right curve. So we know x couldn't be 0, so that's a given. We will definitely go in and put our vertical asymptote in. Okay, just like that. Let me pinch it in so I can go a little bit more on the bottom. Put arrows. But here's the kicker. What does this do? The x can't be 2 either, but I see here's 2 right here, right? I see it on my graph. It's not the fact that it's space or anything like that. But in reality, students, we do have a space there. It's what we call a hole. There's a hole right there at x equals to 2. Isn't that crazy? Right? So because we have a hole, and the reason we have a hole is this, and let me kind of go back up to our equation. Our equation is y equals x minus 2. And then our denominator is x squared minus 2x. But when we factor it out, the denominator, here are the factors, our equation really comes out to be y equals x minus 2 over x times x minus 2. Well, in math, we have to reduce. So after we reduce, our equation came out to be like this. Oops, that's an x. Like this. Well, that's the same as number 1. That's no wonder why we have the same graph. But we always resort back to the OG, the original. Since we have a hole, and when we graph it out, you guys don't have a pen like I do where we just erase, we put a hole right there. Well, then we have to calculate the y value of that hole. Well, to calculate the y value, we know x can't be 2, so I'm going to plug it in here. Y equals 1 over 2. Whoa! So the hole is at 2 comma a half. Yes, a hole is there. So for this one, we have a hole and a vertical asymptote. And remember, we still have that horizontal asymptote here, right? So let's put that back. Yep, that's still there. So that's AB. Now I would like for you to write a comparison for 1 and 2. What did you learn? Okay, how did a hole come about? When would a hole happen?